Hi, this is Barrett Givens, and in this video, we're going to talk about something called the product topology. So the product topology is the topology that is placed on a product space. So just to recall, the Cartesian product of two spaces is what you get when you take two spaces, x and y, two topological spaces, or just two sets, x and y, then x cross y is the collection of ordered pairs of the form x comma y, where little x is in capital X and little y is in capital Y. So it's all ordered pairs where the first coordinate is from capital X and the second coordinate is from capital Y. Okay, so the product topology, let's say you have two topological spaces and they have basic open sets given by cursive b sub x and cursive b sub y. Or it could happen that the basis you're looking at just is actually the whole topology. That's okay too. So if you take the collection of sets of the form B cross C, where B is a basic open set for X and C is a basic open set for Y, then that forms a basis for a topology on X cross Y, which is called the product topology. So the product topology. Now, I've called this a definition, but it's sort of hiding a theorem in it. It's hiding the fact that I say here that this collection of sets of the form B cross C forms a basis for a topology. That actually needs proof. We would need to check that it satisfies the definition of a basis. But I'll leave that for you to do. Okay. So so that is my product topology. And just sort of as a shorthand, when you're thinking about the product topology, so the sort of intuitive idea, intuitively, a set, the basic open sets in X cross Y have the form of being an open set in X crossed with an open set in Y. And this could be basic open or it could be open. You could actually think about it either way. Both work, okay? So that is the product topology. Let's do an example. So the first example I want to think about is, let's suppose that X is the real line with the standard topology. And we'll let Y be the set 0, 1 with a topology given by the topology. The open sets would be the empty set, the set singleton 0, and then the whole space Y. Okay, so how do we picture X cross Y? How do we picture X cross Y? So X cross Y, the elements of X cross Y, this is going to be the set of things. So the elements will look like X comma N, let's say, where X is a real number and N is in Y. So N is either equal to 0 or N is equal to 1. So it's going to look like ordered pairs. It's going to look like all real numbers, comma 0, and then all real numbers, comma 1. So it'll be ordered pairs of that form, a real number, comma 0, or a real number, comma 1. So I can sort of picture it as two real lines. So I can picture it as two copies of the real line. And let's say the top one is R crossed with just 0, and the bottom one is R crossed with just 1. So like a point on here, for example, this would be the point 0, comma 0. This would be the point 0, comma 1. Over here would be the point 5, comma 0. Over here would be the point -2, comma 1. So everything on the top real line is something comma 0, and it looks just like the real numbers, but with this extra coordinate 0. And then on the bottom real line, it's all things of the form something comma 1. So ordered pairs where 1 is the second coordinate. And okay, so that's kind of that's one way that we can visualize R cross 0, 1, R cross 0, 1. Now the basic open sets in X, basic open sets look like open intervals, A comma B. In Y, the basic open sets, well, we didn't actually even give a basis for Y. We just listed the whole topology. So we can just think of the basic open sets as just the non-empty open sets. So the open sets would be either 0, or Y itself, which means 0 and 1, just the two non-empty open sets that are listed. So now when we take cross products of those two kinds of things, the basic open sets in R cross 0, 1 with this topology would either look like an open interval crossed with singleton 0 or an open interval crossed with 0, 1. So I'm basically just taking things of the form of the basic open sets in X crossed with the form of basic open sets in Y. So what would those look like? There's sort of like two types here that we're looking at, right? So type 1 is open intervals crossed with 0. So, uh, uh, points of the form x comma 0 where x is between a and b. So a sort of typical open set of that type might look something like that. That's a typical open set of the form AB crossed with just 0. And then the other sorts of open sets, let me move that. The other sorts of open sets that we might look like would be something like AB cross 0, 1. And so that's going to be an open interval crossed with both 0 and 1 with both points. And so that might look something like this. So it's like the interval from A to B, but on both copies of R. And so this is these two parts together. This is AB cross 0, 1. So those are the two types of basic open sets in this topology. All right. So so that is the definition of a product topology and then one example. Thank you for listening.